Hello friends, welcome back to my shop. We got a million things to go over this week because I missed last week's video, so let's get right into it. So this caused me a lot of extra work that I didn't really plan on. This is my old computer, it's my Linux box that runs my CNC mill and my now CNC lathe. And last week I had a problem with it where it wouldn't boot up. I'm 95% sure it's the hard drive issue on this computer, but the thing is, this is the hard drive out of it. Like I said, I'm pretty sure it has a damaged boot sector. I couldn't boot up to it. It wouldn't even boot from a live disk I have. One more thing. So Smart Kurt, back in the day, made me this, which is a lifesaver. But there. So this is my boot disk. Basically, it's just a clone of the system I was using of Linux CNC. And that way, if I ever have something that totally goes awry, I can just pop this in and essentially just put the whole operating system back onto it. And we're relatively good to go. I couldn't even get that to work, so something was messed up. My biggest, how do I say this? My biggest commodity is time right now. Not to say that money isn't important, but time is the only thing I can't ever get more of. I can always get more money, but I can never get more time. So anything I do, I try to optimize my time within reason. I can't spend a boatload of money to just give me more time by, just shelling it out for no good reason. I'm limited by that still. But instead of trying to hunt down a hard drive for this or get a pinout that would work, I just decided to look on the local marketplace in my area and see if anybody was selling old computers. And it turns out, fortunately for me, unfortunately for other people, with kind of this slowdown due to the virus, there's a lot of companies that are liquidating some of their office equipment, and some of it is old computers. So I was able to get 2 old computers for like $100. Oh, okay. A lot of running around today. So here's one old computer I was able to get. And the other one you can see is actually it's living right there. It's backwards right now. That's the one I decided to go with. These are both like $50. Quad or dual core old computer. You would never use this nowadays. I mean, you could use it for web surfing and a media server or something like that. You'd never use this for anything important these days. But thankfully for me, it worked perfectly. The reason I like this one is it had a solid state hard drive. That one had just a regular hard drive in it, but that one had a better processor or a faster processor. I'm gonna get a chair so it's not so weird here. So this computer actually, I booted them both up. I ran Linux CNC on both of them, so I didn't care what OS they came with. They came with Windows 10 or whatever people. Anyways, I put Linux CNC on both of them and then ran, there's a latency test where you can basically tell how much, it's called jitter in Linux CNC world, but it's essentially how fast the processing unit is running. So when it's streaming out code, because all my code comes on, I send all my code out with a parallel port still. I could definitely buy a Mesa card. I thought about it. I actually put a Mesa card in my shopping cart at this one store, but it would take days for it to get here. And I wanted to be up and running as quick as possible. So these computers are how it is right now. And that also means I don't have to futz with anything here. If I just go with straight parallel port, I can run everything just as I was in the past, and minimizes my downtime. So I took whatever was kind of important-ish out of there, and I put it in here. I put the solid-state drive in here as well. And I put 2 copies of my boot up on the solid-state drive, which is the one I'll be running normally because solid-state, it's faster. And I cloned the exact operating system onto the hard drive as well. So when I boot up, I have the option to pick. So if I ever have a hard drive that drops out, I can just immediately switch right at the boot up screen and jump into the next known good system. And hopefully that'll get me around any hard drive issues, because that's basically the only thing that I think is going to fail in a computer besides the power supply. Now I have a couple of them. And absolute worst come to worst, I could always pull a drive out of here if something else failed on the motherboard, drop it in that computer, and I have a spare that'll run all my systems as well. Because it makes no sense to be basically down for a day because of a cheap piece of hardware. So that's how I fixed that. The next thing was getting the laser cutter up and running. When we last left in my video, I had these. I had this M2 board, M2 Nano, not the Moshi, but yeah, the M2 Nano board. This is what comes with the stock K40. And I thought I could repurpose this using software called Meerkat or K40 Whisperer. I tried them all. And I think I also tried LaserWeb. Anyways, I tried all the software with this board, but you can't actually, as far as I know, you can't adjust any of the firmware settings on this board to account for like different diameter pulleys that you put on the stepper motor. And obviously when I did my conversion, I changed the pulleys out because I changed the belting that I'm using. So I wasn't able to use this. And the fact that this board is just incredibly limiting. I had planned to throw the Rambo board into it, but the Rambo board, while it is a great board, and it's actually what I'm going to use for that thing right there, but like my hair, it's focusing. I had planned to put the Rambo board in that printer because it has lots of new features that printer would work well with. Anyways, I was just going to reuse it for the laser, but configuring Marlin to work with a laser cutter is totally doable, but once again, it's just that time thing. I started looking into how I'd have to restructure the firmware, and people have done it. It's definitely not an insurmountable task, but it would take longer. So I had I'm fairly familiar with Arduino, so I decided to try Gerber. I haven't ran Gerber ever, so I figured this would be a good opportunity to try it. So first, apologies for the craptastic lighting and the echo. We're actually outside of my super bright office in the dark, dungy, echoey basement. But that's where this thing lives. So this is the Gerber board. This is where I had the other board mounted, and you can see how temporary everything is, resting on tape and whatnot. I'm actually really impressed with this little board here. It's got a couple Trinamic drivers, I think they're called. They're the nicer, newer 3D printer drivers. They have more current handling than the stock motors in this laser cutter can take, so that's awesome. I can down regulate them, and everything runs nice and cool. Gerber works perfectly with Lightburn. I used all the other open source and free alternatives to drive laser cutters, and then I tried Lightburn, and it's like $40 US, like $50 Canadian or something like that. Worth every single penny. I'm still on my 30-day free trial because you get it for 30 days for free, but it's a no-brainer for me. Software that just makes life that much easier. Perfect. I'm not sponsoring this or anything, but after going through the frustration of all the free software, just if you're messing with laser cutters, get Lightburn. Don't even mess around with the other ones. It's just so much nicer to work with. It also drives PWM output. I mean, most of them do, but this one also does, and the Gerber board handles it perfectly. The only issue is it's active high, as most things in the world are, but this power supply is active low. So when the signal goes low, the tube turns on. So I had to build this little, is that half-ass in focus? Kind of. I had to build this little logic inverting board. Basically just takes a signal and just flips it so that it can drive the tube. And I put a little LED on it when I was doing testing, so I could keep the laser off and I could fire it, and I could see when it was turning on or off and make sure the PWM was functioning correctly. And yeah, very happy with it. Works great. I'm not going to be putting Gerber on my mill anytime soon, but yeah, for a very economical option for driving a CNC, I suggest it. So this is the completed laser. You can see I put a little plate basically to where the old electronics were housed because they were in this section, which is now part of the cutting area. I have this weird, can you even see it on there? Let's just focus not on me on here. You can see this weird bed I made. I'll put a giant time lapse of building this. It was a good idea. I'm just going to go with a honeycomb bed. I initially didn't know how thick this would be, and I didn't know if I could get honeycomb in the thickness that I needed it. So I ended up just using some aluminum, and I basically just cut it and slot it and kind of pounded it all together. But the process of forming it, my cuts were too tight, and then when I went to put it in here, it doesn't lay perfectly flat. It's not a perfect solution. It works great right now for testing, but I'll probably just put a honeycomb bed in here, call it done, and not have to worry about it again. Nothing too new that you haven't seen in the other video. I put some cable chain on here basically so that the air nozzles, there's two lines here that run to a compressor, or a little like this giant fish tank compressor on the side that pumps air through here, and then it just keeps the flare-ups low. I don't have an adjustable bed on here, so instead what I do, so to account for different material thicknesses, I had to do that by moving the head. I can't move the head because it's built into this big gantry system, so what I came up with, or what most people do, this is an adjustable head. Just put this in here, loosen this. This hole, there we are. This is just the lens assembly. It holds the last focusing lens in there. It's got a little flat. And I can adjust this up and down, little set screw bites into the side. And that gives me enough adjustment to account for different materials that I put in this machine. You could just as easily do this with a moving bed, but a moving bed had a lot more complexity, especially trying to keep everything level, so I just went with the adjustable head. I have the tools to work metal, so it was easier in this instance. Get that back in there. And actually what I have is a little stick here. It's fun to focus. So this is just a little stick, a little piece of plastic tube, and it's set to the same focal distance. So when I put any kind of material in the machine, I just basically set this on top of the material and then loosen the little set screw till the laser bumps up on top of that, tighten everything back up, and my focus is set. And then I can set it wherever I want. If it's thick foam, which I'm mainly using this for, I've set the focus about midway through, and that gives me a pretty decent cut. The last little detail with this cutter is to cool the laser tube. I have this reservoir of water sitting under this cabinet. As we're in my basement, it actually stays kind of cool down here. So this water normally sits at like 18, 19 degrees. Still a little warmer than I'd like for laser cutting. So what I do is I just drop a couple ice bottles in here, like 5-10 minutes before I'm going to start cutting. I let the pump circulate everything through, and it brings the tank down to about 15 degrees, 15, 16 degrees, which is perfect for running the tube. And I have a bunch of them in my freezer, so after, I think it keeps at that temperature for a few hours. It's a big reservoir. It's 20 liters of water. And if it starts to heat up, I just cycle through the ice bottles, and that works just fine for my purposes. The last step that's important with the laser cutter is getting the smells out of here. So you can see in that previous frame, there's a tube just kind of going up into nowhere. In my workshop here, I actually have a bathroom fan that just pulls the air out of this place. I don't really need to pull the air out of here because it doesn't really get all that gross in here. So I repurposed that fan. I basically built a weird little focus on that box, you can see it. There we are. So very not high tech, but it's essentially just a aluminum box that is taped to the roof. About there, sure. And that basically just lets me pump the air from the laser cutter, goes up through the venting, drops down into here, blows into that box, and then it's around the output, or the fan, the bathroom fan that's mounted in my roof already, and then the bathroom fan just pulls it out. Why didn't I plumb it directly into the same connection and just run it directly out? 2 reasons. 1, it was quicker to run it this way. 3 reasons. 2, I still wanted to have it pretty much easily removable, so I just pull that box off and nothing has changed. And 3, it gives me, I can use both fans. I can use the fan that's in the back of that case, which is just a 120 volt computer fan. They changed out the old blower, at least on the stock unit I bought was a steel 120 volt fan, which seems to move a decent amount of air, and coupled with the 110, 150, whatever CFM bathroom fan, it pulls the smoke out just fine. I actually have a giant like 6-inch vortex fan and stuff for my big hydroponics setup that I was going to use to pull the air out, but it's a little excessive. I don't need that much airflow to keep that chamber cool, and it seems to be working just fine. So right now, it's going to live like that until I drywall this room in the next decade. But how does it work, you ask? It actually works perfectly fine. Exactly kind of actually better than I expected. So like I said, the main use is to cut this foam, this super soft foam, because I don't have an easy way to cut it. But now I have a nice, easy way to cut it. So this is the first thing I essentially tried in the laser cutter. And you can see here we got first attempt, second attempt. Eventually I figured out how to blow through this without melting it. And yeah, if you can imagine, it's foam, so it cuts crazy fast. And then I started getting fancy with the cuts, and I built this little thing just to see. So I can actually do engravings onto the foam, and the edge finish is perfect. There is 0 marks of melting. Like, you would never be able to tell I laser cut this piece of foam. Even the engraving on the top is perfect. So I am super happy with that, because that I wanted to put some like markings on the packing foam, so when you open my boxes of whatever I'm selling, mostly pens, but when you open the box, you can I can write text on it. I can have like open here or lift here or all kinds of stuff, and it lets me custom die cut the foam to each pen and do it in a reasonable manner instead of taking me like 10-15 minutes, which is what it probably takes me to package up an order the way I like it. This reduces it significantly. So. And that's also why I extended the bed, so I could put a few of these sheets in there and kind of get it all cutting at once. I mean, at the speed it cuts, it wouldn't matter if I had to keep cycling this in. But anyways, that's why I did it that way. And I'm super happy that it works out that way. I also tried cutting. I had some light ply here, which is just like, this is 1/16 plywood, but it's got a 1, 2, 3, 4, 5, 6, I think 4 or 5 laminations in here. So essentially it's more glue than it is plywood, and it's actually ridiculously hard to cut through. I thought this would be really easy to cut through, but I cut through. I gotta find another thing. One sec. People that say I jump around a lot are gonna have a field day with this video. So this was actually the stick I initially started messing with. Just started engraving. This is actually when it was running without PWM, so you can see everything is really blazed in pretty hard. Once I got the old light burn running nicer, I was able to do a lot better work. But this one still, these didn't punch all the way through. Almost all the way through, but this piece, this is just a piece of maple, but even with its stock, like the same setting I used for plywood, when I cut this, you can see how far it went through. It didn't go all the way through, but it went like 3/4 of the way through this, I don't know, 6, 7 millimeter thick piece of maple. That's just because it's homogeneous through. It's just wood. There's no binder. There's no glue. A lot of people say that with laser cutters, when you're trying to do plywood work, it can be a little more difficult because you're dealing with a lot of glue. And then once you kind of carbonize it, once it gets all carboned up, it's not as effective at cutting through. So live and learn. I don't plan to do a lot of woodwork with it, but I'll eventually try some more hardwood and stuff. The main reason I want it is just for foam. So that works perfectly for me, and I'm happy with that. So by this point in the video, we should have weeded out anybody that was casually observing, and only the hardcores are left. So thanks for sticking around. Last thing to do now, or last thing I can finally say, is we can actually start production on the EDC bolts. I mean, technically I have started production on them, just not in a fun way to say it. I've done like soft jaws, and I've done like some stock prep, and just the boring stuff that has to be done. The one thing I was working on was this. You can see this is a brass tube, or brass piece of stock, but I have these new diamond cutouts, and that's going to be for the new pocket clip. On a commission job I recently did, there we go. The pocket clip I used, the stock one, which is on my pen, it has rounded corners. It just didn't fit right, so I ended up redesigning the pocket clip, or the pocket clip, with a more diamond pattern. Especially with my mill having ball screws, it can do it a lot better now. So we got some really cool patterns that I'm much happier with. They fit that pen nicely, and they look so good that I'm just going to carry it through for the EDC bolt, because it looks pretty, and I like the way of it. So I made new soft jaws that would handle that, and another thing that's always bothered me with my pens is, let's zoom in so you can see, focus in, not zoom in. So this is that same brass piece like this. I've just finished this one more so. This was actually a full cap for the commission job. It didn't, the alignment wasn't perfect, so now it's my test piece. These little itty bitty 256 screws, I always want to, especially ones that aren't going to be removed a ton, I want to put them in place with Loctite, but like if you put in this like red thread locker, it's kind of a no-go. You have a good chance of stripping the screw head out just because it grips so solidly. So I found this stuff, which is Loctite 222, which is purple. I didn't know they made purple. And it's just basically it's for really tiny fasteners like this, and it's just enough force that even with these really small screws and these small drivers to get them out, it's tight. It's not going to ever work out from vibration, which is my main issue. Even on this pen, like these ones, I've red Loctited them in place, but I blue Loctite them actually in place. I don't use red. That's for crazy people. But even blue Loctite can fix it to the point where you're almost ruining the screw head trying to get it out. So this new 222 seems to be awesome. It just kind of provides a nice gummy feel. It doesn't like bite it perfectly, but it'll keep it from loosening just in vibration, and still let you take it apart without being annoying. And it kind of seems to retain on the screw thread, so when you put it back and forth, you don't have to constantly be reapplying it. So that's ideal. I'm happy with that. So we're gonna roll with that. So all new pens that ship out, I'll probably just hit them with 222, because it's not gonna. I think most people that buy my pens take them apart because they're fun to take apart. It's like taking apart a little machine. And I don't want to Loctite the screws and make it annoying to take apart, because that it makes it feel not good. So when I can put it together and then have it come apart still easily, that rambling about Loctite, it's perfect. I like it. I'm happy. We're moving on. The next step for me to do now is just work on the production pens. These are the 2 refills that I'll be using. So this is the standard Pilot G2, and this is the little cute Pilot G2 Mini. Considering the pens are the exact same amount of work despite which refill I pick, the pen is just significantly smaller with this one and significantly longer with this one. My production pens, I actually use this refill, but I trimmed it to try to gain a little bit, or to shrink the pen size. It's too annoying to cut these for the average person. I'm assuming it's just an extra step where if you cut it too short, it doesn't extend right. And I kind of want consistency. I always want that pen tip to extend the exact same amount out of every pen. So I'm going to lengthen the pen by it's super small. It's like 160 thousandths of an inch. It's like just over 1/8 of an inch longer to fit this stock. And then there'll also be a little variant that'll fit this. Those are the next 2 things I'm working on. I'm just excited that I'm finally in a position where everything is lined up now. This is the busiest I've been in the last forever of my life, just still with a day job and doing this and shooting video and getting the laser cutter going and trying to work on production. I just run out of hours in a day. I love it. I'm not complaining in the slightest. I'm addicted. I like, hustle porn is my thing. I love being busy. And I don't know, it's enjoyable. That's all. I'll see you guys next time. Take care. Bye.